Welcome back, ladies and gentlemen, continuing our exploration of carboxylic acid. Here we have a new reaction to make carboxylic acid. There's cyclopentane carboxylic acid right there. Carboxylic acid. There's an N there. Organolithiums and Grignards always behave the same. You cross off the lithium, put the lone pair on the carbon and its charge, and attack the carbonyl. You may not combine this with step 2. If I have steps 1 and 2 separated, I need to see the result of step 1 before you add the chemicals in step 2, because that's how it goes in the lab. You must finish step 1 before you do step 2, or else there will be a disaster. I do not want to try to remind you what will happen if you mix the strongest base you can possibly think of with one of the strongest acids you can think of. You get cyclopentane and a lot of heat. I have some lab students who mixed some strong acid and strong base just last week. And one of them right here commented on it. Oh, it's nice and warm. Yeah, imagine that multiplied by 100. And you're making cyclopentane as a product, which is a fuel. Heat and fuel, boom. So if you try to combine steps 1 and 2, tell me so I can run away, okay? So don't do that, okay. And we got our new carboxylic acid, almost. We got an O- on top. The old carbonyl survived. Now step 2 happens and you have it written right there. It's not a bad deal. It's not a bad mechanism, is it? And it's fun to do this one in the lab. You make your organolithium in a flask and then you add dry ice. What's dry ice? Solid CO2. It'll bubble and froth. It'll look like a rock show. Seriously, it'll be bubbling and frothing, and a lot of when the cold CO2 hits the air, it takes the water in the air and condenses it to white steam. It looks like fog. It looks like fog above your reaction. And that's TMI. It's not a lab class. Next is all of these chemicals together here. And this is a very reactive sulfur, because you don't almost never think of a carboxylic acid as a nucleophile. That's not something it does. It likes being an acid. You know that. That's why they called it an acid. But here it's not being an acid. It's attacking sulfur with its lone pair. You're getting an O-. O- is going to come back and kick off one of the CLs. You can combine those 2 steps. Oh, that's not red. You can do that because that lone pair in green can come back and make a pi again and kick off CL. It's a little small there, isn't it? I want to make sure you know you're remaking your pi bond there. So attack is first. You get an O-. That's what the red says. The blue says the O- lone pair comes back, kicks off the leaving group. You are currently down here. You got your cyclopentane. Got a bad spot on the screen. There's no dirt or anything there. And I don't know what I'm drawing. Yeah, I got the O, oxonium after the carbonyl, and SOCl. O, carbonyl, O, S, Still has a double bond to O and one Cl left. And Cl minus got created. And we have an oxonium, pretty sure. Yeah, we did not get rid of that H. Now we can look at the top of the screen. Oh, said oxonium. I didn't write the yum, did I? We'll lose a half point. There we go. Oxoniums are strong acids. Pyridine is a mild base. Has a lone pair. Grab the H. Neutralize your oxonium. We're getting there. And there we go. Got work to do. How's that Cl going to end up on the carbonyl? Which Cl ends up on the carbonyl? I got two of them on the screen right now. Nope. That one's going to be part of the chloride that leaves. We already have a chloride and it's a nucleophile. Going to attack, and what's going to break first, sigma or pi? Oh, don't say sigma breaks before pi, ever. Pi is weaker. And then lone pair comes back and kicks off. You want to make SO2 gas, which means you're going to make your other bond to oxygen a double bond. And my question remains, what breaks first? The bond to Cl, which is a sigma, or the second bond to oxygen, which is a pi? Second pi. And then the lone pair on the O comes back and kicks off Cl. There's a nice little story in there, isn't there? Always breaking pi before sigma. Then the pi is reforming and kicking something off. And then I did it again. Broke a pi before a sigma. Lone pair came back, regenerated a double bond, and kicked off. Kind of a theme. And there you have it. And this is an acid halide. We're going to see a lot of that in chapter 18, which is the next chapter on this test as well. So look forward to acid halides because they're very reactive in a different way than carboxylic acid. Let's copy that down. Take your time, because I have to make up a new activity.